Hi grade 9s, welcome to 6.5, which is the last sort of section in our inequalities unit. So we're getting close to doing our, we're going to do a quiz on 6.3 to 6.5, and then we're going to do a practice exam, and then we're going to write the unit exam. So it's a relatively quick unit. And those of you who did well in units 4 and units 5, I mean, you know the content is very similar. If you can solve an equation, if you can isolate variables, it's really not much different doing it with inequalities than it is just doing it with an equal sign. You know, you understand at this point terms and variables and how to solve for variables. So it's good to see that people are continuing to do well. And it's also good to see that people that maybe did struggle with one of the earlier units are look like they're really starting to put it together now. So keep up the good work, keep up the hard work, and we're going to move on to 6.5. I mentioned in the last video that this is quite a quick section because you really understand about, I'd say, 90% of what you need to know already from 6.3 and also from 6.4, the addition and subtraction. So we're only changing the operations here, and as long as you can remember one key rule, you're going to be just fine. So what I've got here is I've just got general instructions here that we can kind of prove to ourselves what happens when we're multiplying and dividing using an inequality. And we already did this in 6.3, so even this is kind of a review. Let's look at the instructions down here, and let's look at what we've got to start with. Okay, so we've got our multiplication and we've got division. We've got a statement that is true and the same for both. We say that 12 is greater than 6, and that is true, right? So what happens if we multiply by 2? So we've got to multiply both sides by 2, okay? And we've got 12 times 2 is 24. And then we've got 6 times 2 is 12. Now, does this still hold true that 24 is greater than 12? Yes, it does. So it's still true. Okay, and you don't need to put anything here. How about multiplying by negative 2? Okay, same process, except in this time, let's multiply by negative 2 instead. Now we've got negative 24, okay, is greater than negative 12. Is this true anymore? No, now this becomes false. Right? That's not true. Negative 24 is not greater than negative 12. It's less than 12. So we're just kind of proving to ourselves what happens when we multiply or divide by negative numbers. And I think you already know what's going to happen when we do the division pattern here. So if we divide both of these numbers by 2, we end up with 6 is greater than 3, which is still true. So that was by a positive number, right? So this is a positive number. This is a negative number. This is a positive number, and this is going to be a negative number. And as you know from 3, we've already done this in 3. If we divide, or 6.3 rather, if we divide by negative 2, it becomes false, right? 12 divided by negative 2 be negative 6. Is negative 6 greater than negative 3? No, that is false. Okay? So that's why we had to make up that one rule, and that is when you multiply or divide by an inequality, when you multiply or divide an inequality by a negative number, okay, you must flip the sign. You must flip the sign. And when I say sign, I mean the the negative, greater than, or sorry, the less than or equal to, greater than or equal to, less than, and then the equals to. Those are the things that need to flip. I wonder if I should phrase that differently. You must flip the sign. A better word that I used for that. Yeah, no, it's a sign, I guess. I just don't want you to get confused with the sign being like a negative sign. It's not the negative sign that's flipping, it's the operation sign. So just make sure that you're clear that when we see you flip the sign, maybe I'll put e.g., that's for example, that flips to, so greater than flips to less than, right? Just so we keep that clear, so people aren't like making negative signs disappear or something like that. Okay, so let's solve. We know how to solve these. We've done them with equations. Now we're going to do them with inequalities. And then the whole point of this is in solving for these, we're probably going to have to flip the sign, right? So if we look at this, we've got negative 5x is less than or equal to 25. We already have the variable isolated on one side. We've got the constant on the other. but we need to get rid of the -5 coefficient, right? Because we want x alone, we want the -5. So we got to divide by -5. So because we've divided by a negative number, we have to flip that sign. So let's flip it to greater than or equal to, that would be -5. So this is just practice, getting used to the fact that if you were dividing both sides by a negative or multiplying both sides by a negative, you got to remember to flip that sign. Same thing over here. We've got 7a is less than 21. That is true. Okay, we don't care about 7a. What we care about is a, so we're going to have to divide both sides by 7. Now, you should get into the habit, I think I noted this in 6.3, you should get in the habit of writing the sign first. It'll make it less likely that you mess it up. So we are dividing by a positive number, so the sign doesn't need to change. Now I just got to figure out what to put on either side. So 7's cancel for a, and then 21 divided by 7 is 3. So that would be your final answer, and I did not swap the sign, right? And this one. And then I swap the sign on this one. Swapped, flipped, same thing. Now we'll solve it and we'll graph it. And it'll be the same process. Okay, we've got x over -4. Again, we don't need to be panicked by fractions at this point of our academic career. We know what to do with them. What's the opposite of division? It's multiplication. So if we multiply the top of both numbers, or both sides rather, by -4, we're going to get rid of that fraction. But because we're multiplying by a negative number, the first thing we should do is we should flip that greater than sign and make it a less than sign. So the -4 on the top cancels with the -4 in the denominator, which just leaves us with x. And then over here, we've got a negative times a negative, which is a positive. So our answer is x is less than 12. So let's check that out on, I think I'm going to verify it over here, but I'll just plot it out quickly here. So if this is 0, 2, 4, 6, 8, 10, 12, 14, 16, and -2, -4, we are less than 12. So let's circle 12, but not fill it in. And then we need to shade our line in the less than direction. Okay, there we go. Let's pick a value that's less than 12 to verify. Okay, so let's pick one and see if it still holds true. So x is 1 over -4. Is that indeed greater than -3? Well, this is the same as -1 over 4. Okay, you can write it. You could just bring the negative sign to the top. So let's look at our number line and decide, is -1/4 greater than -3? Well, -3 would be right about here, and -1/4, that's not even, that's less than -1, right? So -3 would be here, and -1/4 would be right about there. And we know that anything that is on the right side is going to be greater than the number on the left side. So that does check out. We can check another number. Let's check with x equals 4. 4 is still less than 12, so it still fits with what we think the answer is. Okay, so here's our second check. Now we're looking at x over -4, so that would be 4 over -4. Is that greater than -3? Well, 4 divided by -4 is just -1. Is -1 greater than -3? Sure it is, because -1 is going to be right here, and -3 is still there, so it still holds true. So our verification worked out. It didn't say specifically to verify this one, but it's really easy to do. Just make sure that you remember what, sort of the parameters of x have to be. And if you put in, x was 24, then this would no longer hold true because we said it had to be less than 12. That's sort of a way, you could do that. It would just be sort of checking by knowing you're going to get the wrong answer. How's that? Okay, x over 3 greater than or equal to -2. Let's see here. We've got. I'll make sure I flip the sign there. Okay, good. We've got a positive 3 in the denominator, so it's division. A fraction's division. So if we're going to get rid of that 3 in the denominator, we've got to multiply both sides by 3. Multiplication is the inverse operation of division. So we've got a 3 in the numerator and a 3 in the denominator. Those cancel out, which just leaves us with x. And because we are multiplying by a positive number, we do not need to flip the sign. So we're going to keep our sign, and then negative 2 times 3 is negative 6. All right. Let's do a quick verification. Won't take us very long. Verify. We need to pick a number that is greater than or equal to negative 6. Well, I would say that 0 is greater than or equal to negative 6. So let's check it with that one. So we've got 0 over, what was my original number? It must have been 3a. 0 over 3 is greater than or equal to negative 2. Well, that just says 0 is greater than or equal to negative 2. Is that true? Sure it is. 0 is greater than or equal to negative 2. Now let's verify with, it says equal to, so let's verify with, you don't have to pick it, but let's try with negative 6. So we've got x over 3, so that would be negative 6 over 3. And we're checking, is that greater than or equal to negative 2? Negative 6 divided by negative 3 is negative 2. That is indeed equal to negative 2, so that checks out as well. So both of our substitution verifications checked out, and now we can feel pretty comfortable plotting this on our number line. So greater than or equal to negative 6, I know I got to start at least negative 6, so let's go negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12, and so on. Negative 6 is where we start, so we're going to circle it, and it's in greater than or equal to, so we're going to fill it in, and we're going to assume it's continuous because they don't give us any other information. And then we just got to make it greater than, which means sending it all the way this way. All right, we'll move down here again. Solve 10 minus 2m. There's just one more step with this one because we have to isolate the variable, but it shouldn't cause us any difficulty. 10 minus 2m is less than 16. Well, let's get that 10 to the other side. I always want to keep my variables on the left side if possible, right? So we're going to have to subtract 10. Okay, positive 10, subtract 10. And remember, signs don't change with addition or subtraction, so I don't have to do anything yet with the sign. 16 minus 10 is 6. Now, however, though, I have negative 2m, and I need to divide the negative 2 out of there. So if I'm dividing by a negative, that means I know right away my sign has to flip. So that leaves me with m on this side, and 6 divided by negative 2 is going to be negative 3. It doesn't ask us to graph this one, it just asks us to verify it. So let's pick a couple numbers that are greater than negative 3 and make sure it works. So let's verify with m equals 0 and plug it into our original equation. So 10 minus 2 times 0, because 2m, is that indeed less than 16? 10 minus 0, because 2 times 0 is 0, is that less than 16? 10 is less than 16, so that checks out. And let's also test with negative 2. Okay. So we'll check with negative 2, and so it would be 10 minus, and then it's 2 times m, which is negative 2. Is that less than 16? We've got 10, and then we've got minus 2 times a negative, so that actually becomes positive. So that's 10 plus 4. Is that less than 16? Yes, 14 is still less than 16, so that checks out. So we verified, and everything's good. So solve the inequality and graph the solution. And I notice I don't have another number line, so I might have to actually sketch one. Okay, this is all from Unit 5. It's just recognizing like terms and making sure that you don't make any sign errors. I want to get all of my a's on the left side and my constants on the other. And I always said it's not a bad idea to make yourself some little notations. Which are the like terms? Well, the two that contain a's are like terms, and the two that are just numbers, they're constants, they're also like terms. Let's get our a's to the left here. So I have to subtract 1.8a in order to get rid of it on this side, which means I also have to do the same thing on the other. So minus 1.8a. I'm starting with negative 2.6a, and I'm going more negative, right? So if I'm going more negative, it's going to be a bigger negative number. So that's going to be, what is that, negative 4.4a. And I haven't done anything to anything else yet, so I'll just leave the 14.6. Doesn't matter, adding, subtracting doesn't change your signs at all, so I'll leave the sign the way it is, and then I've got negative 5.2 on this side. Now this canceled out, that was the whole point. So now I've got to bring the constants to the right side. So I have a positive 14.6, got to subtract from both sides. So I've got negative 4.4a, and then that is canceled and still greater than. And then I've got a negative 5, and I'm going more negative. So I'm actually getting all the way down to negative 19.8. All right? So now I have to do some division, and I have to divide. I'm just going to give myself a little bit more room here. I have to divide by a negative number, because currently I'm at negative 4.4a is greater than negative 19.8. So in order to get rid of the negative 4.4 as a coefficient, I need to divide by negative 4.4, and I have to do that to both sides. So now that I know that I am dividing, red marks. Now that I know that I'm dividing by a negative number, I instantly flip my sign. Okay, so I'm left with a, and then what is negative 19.8 divided by 4.4 is a positive 4.5, because I had a negative divided by a negative, so that's a positive 4.5. It doesn't ask us to verify it. It does ask us to graph it. I did not put another number line in here, so this might look a little ugly, but let's see what we got here. Okay. This is black. What are we looking at? A is less than 4.5. Okay, well, let's put our 0 here in the middle. Let's say that's 2, 4, and then this would be 6, and then negative 2, negative 4, negative 6, making sure they're as evenly spaced as possible. 4.5, well, this is 5 right in the middle between here, so it's going to be right about there. So what I'm going to do is, I should do it in a different color, that purple maybe. So I'm going to circle, and I'm just going to make a note right there that that is 4.5. And then I need it to be less than 4.5, so I do not fill in that dot. I keep it as a circle, and then I know it needs to be less than that. So I'm working my arrow toward the left. And that is all it asked us to do. So that was a quick unit, right? You know how to add and subtract. You know how to work with like terms. You know how to verify. The verification by substitution looks a little different on this one. That was something that some people struggled with in Unit 5. So make sure you understand how you're verifying using 2 or 3 or however many different numbers you're substituting in. Make sure you understand that process. And please do the textbook practice questions. They are very similar to the things that you see on the quizzes and on the unit exam. And so if you're having, any questions about them, if there's any difficulty with those concepts, when you're going through the practice questions, really all you need to do is send us an email and say, I'm having trouble with page 308, question number 4. And then we can help you with it, and you'll be good for the quiz and for the unit exam. So please don't hesitate to reach out for help. And this is the end of Unit 6. So we're going to have a quiz on 6.3 to 6.5. And then we're going to look at the practice exam and review, and then write the unit exam. Let us know if you have any questions.